how to memorize anything faster. My name is Grace Martin, and I'm your science teacher of today, but you can use this memory tool and apply it to any other concept. So I'm going through the scientific inquiry process. We're going to do a bit of a guided visualization for memorizing the scientific process. We're first going to walk through the visuals, close our eyes, imagine each one, and we are going to memorize by the end of the video. This is also called the scientific method, and it starts with a question. So I want you to imagine a quarry, maybe a quarry of quartz, because we need some cue terms to remember question. So where are you at? The quarry. What's at the quarry? Okay, maybe we're going to ask a question about how impurities affect the color of quartz. So you're at the quarry, you're asking a question. At the quarry, you start to walk toward this trailer, which is the headquarters at this quarry. So at the headquarters, we need to state a hypothesis. So I could state a hypothesis that maybe quartz are clearer when you have fewer minerals in them, so fewer impurities. We are at headquarters, and we are stating our hypothesis. Now, inside of headquarters, I want you to go up the steps, go into this trailer where the headquarters are. There's a desk in front of you. You sit down at the desk, and the desk symbolizes the design of the experiment. So experimental design at the desk. You're going to sit down, and we're looking at experimental design. On the desk, you see 3 different objects. The first object that you see when you sit down is a statue of a small little man. That's going to stand for the manipulated variable. Of course, we know that in an experiment, the manipulated variable is the thing that the experimenter changes. To manipulate means to move around, to change. Then you see a little toy car on the desk. That car is going to stand for the controlled variables. The controlled variables in an experiment are the things that are kept the same. So things like location, size, temperature, the different type of crystal, right? The only thing that we're looking at is mineral content and coloration. So everything else is controlled. On the desk, you see a resume. The resume is going to stand for the responding variable. And of course, the responding variable in an experiment is the thing that you measure. So what are you measuring to see? The result of the experiment is the responding variable. Okay, so we are at the desk with the experimental design. The experimental design needs to think of the manipulated, controlled, and responding variables. So at the desk, there's a little statue of a man, there's a little toy car, and there's a resume, to stand for manipulated, controlled, and responding variables. You get up from the desk, you go outside, and you see this beautiful peach tree. Okay, at this peach tree, we are thinking peach tree needs to be where we carry out a procedure. So the procedure is actually doing the experiment itself. But you can't just look at this peach tree. Oh, there's this gorgeous, juicy peach just waiting for you to reach up and grab it. So I want you to collect the peaches. Collecting these peaches is just like you collecting data in an experiment. So you need to collect and record your data. In our example, we're collecting and recording data on the levels of impurities of quartz, because remember our question was at the quarry on quartz. So we're collecting data by taking these peaches off the tree. The next thing we are going to do is look down at the ground, because you dropped a peach. Oh no, where'd it go? Looking down at the ground, you see these little ants around. There's an anthill next to the peach tree. So since there's an anthill next to the peach tree, we think the ants are going to analyze. That's where we are going to analyze. So ants allow for the flow of data. So they are very, very organized. If you didn't know, ants will take the same path from the anthill to where they are going and the same path back again. So their outgoing and their incoming paths are going to be the same. We at the anthill are going to analyze our data, organize our data, and analyze it. Then at the end of the day, in this beautiful quarry, there is an awesome concert. So at the end of the day, there's got to be a concert to celebrate. This quarry is pretty awesome. It's got great acoustics. So there's going to be a concert in the quarry to conclude the end of the day. At the end of an experiment, we need to state our conclusions. We need to celebrate what we have found. So we could state that there is a correlation between mineral impurities and the color of crystal based off of the data that we found. So that would be our conclusion that we state at the end. So now I want you to close your eyes and I want you to visualize that you are at a quarry. At the quarry, you are going to ask a question. And you ask this question and then look over at the headquarters. You go over to the headquarters and you state a hypothesis at the headquarters. You go inside of headquarters and you see a desk. You need to analyze your experimental design at the desk. At the desk, you see a tiny little man, a toy car, and a resume. Manipulated, controlled, and responding variables are the component of your experimental design. You're going outside, you see a peach tree. That stands for the procedure. You've got to collect a peach, so you're collecting data and recording that data in your procedure. You look down and you see an anthill. You need to analyze your data. And then at the end of the day, this awesome quarry has great acoustics for a concert. I need you to conclude your statements, conclude based off of the data that you have received. So that is a great trick for memorizing anything, associating in an image with the topic that you are looking at, but you guys did a great job. I'm super proud of you. Go ahead and try this with another topic.